3 minus 4x, we need to deal with both of them. And if it is 1 minus 4x, this is a, this is b. So wherever a will come, it won't matter what the power is. So we can write a simplified formula in those cases. See, till now what was happening? It was a raised to the power n. See this? This was a raised to power 1, a raised to power 2,
Yep.
a raised to power 3, 4, 5, 6, 7. Whatever the term was, whatever the series was. So it started with a raised to power n, right? And in the very first, b was 0. Then we had a raised to power 1 less than that, n minus 1, and b was 1.
Oh, I
Then we
see.
had a another less, b another more. Getting it?
Yep.
I'm writing that in order. What about the number? What about these numbers we've written? 1, 7, 21, 35, 35. So this is where the monomial expansion comes in. So we're
Okay.
going to write the first one is always a raised to power n plus this is that number nc1 a n minus 1 because a keeps on reducing and b keeps on increasing plus and c2 a n minus 2 and b2 and when it is ncr a n minus r br. So a keeps on reducing till the last one. A disappears, the number disappears, and we are left with only b raised to power n. And what I'm trying to say is when we have 1, we just do not write a and write everything else because it won't matter what the power is. So that's always just 1.
But I don't understand the C for the bottom one.
Okay, I'll show you. Plus nc1 b1. I'm disappearing those a's. nc2 b2 because a is just 1 in this case. And we continue ncr br. The last one is going to be br. Okay, I'll show you what c is. I'm writing this 7th line. 1, 7, 21, 35. 1, 7, 21, 35, 35, 21, 7, 1. 35, 21, 7, 1. Done. You're familiar with this. No confusion?
No.
Okay. Now, use of C. If I have anything raised to power 7, see, there's no C in the first one. Then I start with the second because first is 1 plus either it is 1 or it is a raised to power n. See this 7? I'm writing NC1. Then I'm writing NC2, NC3, N. I don't need to write N, I need to write 7. I know this value. 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7 is 1. Either we write 7C7 or we directly write 1. Similarly, 7C0 is also 1. Now on your calculator, can you see the button multiply, multiplication or division? You will see
Yeah, I
something
can.
like this and something written like this. We need this NCR. You
C
define
is just basically a number
C is a
that
formula which handles this number. Now type 7C0. Are you getting one?
just have to take my calculator out. It's right above the multiplication button?
Yes.
Yeah, I see it. Okay.
So punch 7, then press that button. If it is above that, we need to press shift button as well.
Seven, shift. It just gives me C.
Yes. Then you
It
type 0.
doesn't give me NCR, it gives me just C.
Yeah, you're right. You've already written 7 in place of n. Then you're getting C. Then you type 0.
Okay.
And are you getting 1 when you press equal?
Yeah, I'm getting 1.
Now replace that 0 with 1. 7C1.
I'm getting 7.
Then replace it with 2.
21.
Keep going. What are you getting?
35 after 3. And 4 is 35 as well. 5 is 21. 6 is 7. 7 is 1. 8 is 0. 9
No,
is 0.
it just stops.
Yep.
So see, 1, 7, 21, 35, 35, 21, 7, 1. You're getting these. And you're also getting zeros. If you do it by mistake, so 0 multiplied with anything would just disappear. So binomial expansion, this formula is giving you 1, 7, 21 and all. If someone asks me to write Pascal's triangle till 9, I cannot write the ninth directly. I'll need to draw that triangle starting with 1, 1 each. But if someone is telling me to start solving 3 plus 9 raised to power 17, I can do that directly using this formula. Let's say 3x plus 9 raised to power 17. So this is 3x raised to power 17 plus 17 C1 A 17 minus 1 and B1 plus 17 C2 A2 less and B2 and so on. The formula actually gives you those values directly without drawing the triangle. Now you need to get familiar with the formula. A plus B power n, write few terms and you'll get used to it. A power n, now n C1 A n minus 1 B1, n C2 A n minus 2 B2. See, A is reducing, B is increasing.
Yep.
n C3 A n minus 3 B3. It keeps on going.
Whatever A is decreasing by, B is increasing by that value.
Yes. A n minus 4 and B4 and keeps going. It is easier with numbers. If I write x plus 3 raised to power 7. So this is x raised to power 7 plus 7c1 x raised to power 6. I don't have to need to write 7 minus 1. I can write 6. These are numbers now. And b1 plus 7c2 a 7 minus 2 b2 7c3 a 7 minus 3 b3 and so on. If the power is large, the examiner is never going to ask you to write all those terms. He'll either tell you to expand it till x5, till x cube, or write down the first 4 terms, something like that. Try this solved example. 3 plus 4x raised to power 5. See if you get the same answers.
So at first, it's just the first, it's just the first value to the power of 5, because that's the A value.
Yes.
And then 5, because it was 5C0, now it's 5C1. And then 3 decreases, so 3 to the power of 4. And then the B value, so 4x. And then 5c to the power of 2, and then 3, and then 4x2, and then 5, 3, 3, 2, 4x3, and then 5c4, and then 3, 1, and then 4x4, and then 5c5, and then no 3, and then 4x to the power of 5. Yep. So I'm getting the same answer.
Okay. Now this is x at one place. Difficulty level of question will increase and we'll have x at both places, sometimes fractions as well. This is another formula in similar case. We won't actually need it. We'll handle with the C thing. That sort of manual expansion. Now see, it says write down the rows of Pascal's triangle using the combination notation. If he's talking about row 5, that is something raised to power 5. So we'll write 1 raised to power 5, then use 5c1, 5c2, 5c3, 5c4, 5c5, and that's it. We can have the row 5 directly. Okay. Same formula. And let's try those harder ones. What do you say, K or L for now?
The harder ones, right?
Yeah, out of these two, K or L. Choose one. I'll do with you.
Mm,
Let's do both. First K and then L.
okay. Can I try L?
Yeah, ultimately we'll do them.
Okay.
Just trying to get used to different type of questions. See, A raised to power 5 plus 5c1 an minus 1 b1 5c2 an minus 2 b2 5c3 an minus 3 b3 5c4 a5 minus 4 b4 and 5c5 is 1. I don't need to write that. 5 minus 1 will be 0. I don't need to write that. Last term is directly b raised to power 5. Now I'm simplifying. X5 and I'm using calculator. 5c1 is 5 x4 into minus 3 by x. I won't go for direct simplifications if I have less practice. Okay. And see, in this series, power is also reducing by 2 in every step. X5, X3, X1, X minus 1, X minus 3, X minus 5. Are you getting these answers?
Yeah, I am. Are we going to do L part?
Yes. Try this.
Oh, for this one, it starts with x squared. So do we add the two? No, no, we multiply the two exponents, right?
Similarly, x square is a, 1 over 2x square is b.
Oh, so we just keep the exponent with the actual. Okay.
Yes.
Okay, I'm done.
Okay, let me show the answer. 11.2 to the last part. 11.2, question 2, and the last part. X12 plus 3x8 plus 15 by 4x4 plus 5 by 2 plus 15 by 16x4 plus 3 by 16x8 plus 1 by 64x12.
Oh, I didn't multiply the exponents inside, but it should be in the same way. So it's just unmultiplied inside, I guess, but it's correct. X to the power of 12. And yes, 3 x to the power of 8 plus 6c squared c2 or yep, 63 that cube or 2x squared 3 plus c 5x 5 plus final, so 1 over 64x 12, 1 over 64x 12. Okay,
Same answers now?
yep.
Okay. Now all these are practice questions. But one thing, we need to learn one thing. Find the term in x cube for each of the following expressions. Now, luckily, all these questions, the first term is just the number 2, 5, 1, 3, 1, 2, 10, 4. So there's no x. X is only in the second term. That is x, x, 2x, 2x, and so on. Now, if you would realize the formula is n c r a n minus r b r. So whatever happens, we have no concern with NCR for x, no concern in this case, but x will be in B. So I'm very clear when the value of r will be 3, only then we'll have coefficient of x cube. So we don't have to solve it entirely. We can directly write that if it was 1 plus x raised to power 10, when r is 3, and C3, A 10 minus 3, B 3. So this will be coefficient of x cube. That's 10 C3, and I'm getting 120 x cube. So coefficient of x cube in this first expansion is just 120. If I'm looking at B part, this is 1 plus 2x raised to power 8. So this will be 8C3, 2x raised to power 3, and 8C3 is 56 times 8x cube. So 56 into 8 is 448, and the coefficient of x cube in the expansion of 1 plus 2x, R8 will be 448. Getting the idea? We'll have to think if there is x in two different places, just like in these examples. You see, this was x and x in denominator, so it started with 5, then we have 3, then we had 1. So we'll have to either think or solve. We will solve. There's a way. I'll show you. We'll solve. But till then, this complete exercise other than question 10. Practice 1 to 2 questions and then I'll jump onto that concept. Try. Oh, that was the statement of question 3, and I'm solving on question 4. But try G part. And that's a very large number.
Can we go back to like the pyramid to see what 7 looked like?
Sorry?
Can we go back to the pyramid to see what 7 looked like?
No, you don't need that.
Oh, you can just do 7C0 or 7C1, right?
No, we use calculator. See, this is 10 minus 3x power 7. And we know x cube will be when we are using 3. 7c3, 10 raised to power 7 minus 3 minus 3x raised to power 3. This is the only time when you will get x cube. So we can solve this directly. We don't need the first two terms or the last all terms.
Okay.
7c3 is 35, 10 raised to power 4 is 1, 2, 3, 4, and minus 27 x cube. So that's 35 into 10,000 into 27, getting negative 945,123,4 x cube. Try H part.
So this would be 10C to the power of 3. I don't know. Yeah, 10C3 and then 4 um 10 minus 3 and then negative 5y to the power of 3.
Yeah, let me check the final answer. This is question 3 H part. See if you're getting this number. I'm not sure if calculator screen will show all those digits.
This was H part, right?
Yes, H part.
H part question 4 or is it the H part on the bottom or H part on the top?
H part on the top. Coefficient of x cube. This one at the top.
That's not what I'm getting. I'm getting Y. not x. Maybe I copied down the wrong thing.
This was the question. 4 minus 5x raised to power 15.
Oh, I was doing 4 on the bottom.
Okay, that says plus 3 terms. Quickly do this one again. 4 minus 5x raised to the power 15.
Okay. I'm getting negative. It gives it to me in normal way and it gives it to me in scientific notion as well.
Yeah, anyway, number would be same. Both are acceptable.
That is not what I'm getting.
Okay, let me do that. Did you try 15c3 4 raised to
Yep.
power 15 minus 3 and
Yep.
minus 5x raised to power 3?
Yep.
Okay, and doing them individually. 15c3
Oh, I
is
think I know what the issue is. Instead of multiplying negative 5 x to like both of those with 3, like to the power of 3, I just made it so it's together. So it's negative 5x cubed, not changing that. Yeah, I didn't put 125.
okay. So multiply just the numbers and see. Also not getting the same numbers. 15c3 4 raised to power 15 minus 3. Oh, that's 12 by root 11. 4 raised to power 12. 16777 216. Now I'm getting same numbers. So it's 9.5420416 into 10 raised to power 11x cube. Are you getting now? Same numbers.
Yep.
Try question number 5. Write down the ascending power of x, first 4 terms in the expansion. Now there's no skipping. We write the first, then second, third, fourth. Or I'll do question 5 and then you can try question 6. 5 is easier. I'll do that. But the type is same. It says 1 plus 2x raised to power 6. And we need the first four terms. So first term plus 6c1 2x raised to power 1. 6c2 2x raised to power 2. 6c3 2x raised to power 3. First four are done. 1 plus 6c1 is 6 into 2x plus 6c2 is 15 into 4x square plus 6c3 is 20 into 8x cube. That's 1 plus 12x plus 60x square plus 160x cube. Same question B part. It says find the coefficient of x cube in the expansion of this. 1 minus x of x by 3 into 1 plus 2x raised to power 6. Now this is not a very lengthy question. I can copy down all the terms, but when it is lengthy, I need to choose them wisely. I need the coefficient of x cube. So 1 will get multiplied with x cube term and give me x cube. So I'm interested in that term and I'm copying only that term, which is 160 x cube. And this term will multiply on the other side with x squared term. So I'm interested in that term as well, which is 60x square. And these two will give me nothing because when 1 will multiply with them, that will give me 1 and 12x. And when x will multiply, that will give me x and x square. But I'm only interested in x cube. So I've copied those and left the others. So 1 into this is giving me 160x cube. And I'm leaving the other 1 into 60. I'm leaving that. Then I'm getting 160 by 3, negative 160 by 3. Sorry, this is x4. So we leave that. So this multiplies with this 60 by 3 is 20, negative 20 x cube. So finally 140 x cube. So write down in ascending powers first four done. Coefficient of x cube in this case is 140. Okay, question number 6. Let me verify that as well. Number 5 was 112, 60, 160 and 140. Question 6.
Should I also do question 6, right?
Yeah, question 6. That is exactly like question 5. A little, would say, difficult terms or fractions.
So when it says an ascending powers, so it's just basically from the beginning to 4.
Yeah. When it says ascending power or descending power, that is just for saying, because we know B will be 1, then 2, then 3, then 4, then 5, then 6. Definitely it is in ascending. And
Okay.
first four terms, so when we're done with first four, we stop there. That will be till when the value of r is 3.
Okay. And then B part is just we would first multiply them together and then afterwards.
Now we'll use the expansion from part A in B part. This is exactly as we did question 5.
Oh, okay. Is there another binomial theorem? Because I remember like seeing if there was another one or like it was another way of writing it.
Another like a different formula.
Yeah, it's like a different formula, but it's also the binomial theorem still.
Yeah, one is 1 plus b raised to power n, the other is a plus b raised to power n, and third one is this. This is the expanded form. We only need this when we have negative powers or in fractions because NCR can't handle negative terms or decimals.
Okay.
Is the first part done? Question 6.
Yes.
Okay, I'll
One.
do B part. I'll do the question 1 part.
Okay.
Are we getting same first? A part answer.
Yes. So 1 plus 13x over 2 plus 39 over 2x squared plus 143 over 4x cubed, right?
Yeah. Now B part says coefficient of x cube in this
I
expansion.
got 377 over 4.
377 by 4. I'll quickly do it. 1 plus 3x. So when I multiply x with the cubic expression, I will get x cube. And I multiply x with the squared expression, I'll get x cube. So 1 into this is 143 by 4x cube, and 3 into 39 by 2 is 117 by 2 x cube. So 143 by 4 plus 117 by 2 is 377 by 4x cube. Perfect. And now we're moving on where we need to decide that what should be the power, what should be the value of r to get any specific coefficient or something. Let's see,
Okay.
we have question 10. It says
So
find
that's
the
just the
coefficient of
first
x.
x.
Sorry?
So if coefficient of x, so that's just the first one, right?
No, that would be x raised to power 7. That is not the first one. See, this is the thing. When we do this, x minus 3 over x raised to power 7. If you are expanding it, this will start from this point. Plus 7c1, a 6, and b will be 1. Now see, the first one is x raised to power 7. The second one is x raised to power 5. Then this will be 7c2, x raised to power 5, and minus 3 over x raised to power 2. This is x raised to power 3. I'm writing all these, then I know that this is 7, this is 5, this is 3. I'm still not there till x. But we don't need to write all the terms. There's a way we can do that directly.
Oh, because x, just to get x, it would be 1, and that's with 7.
We don't have to do the mental math. We don't have to think which term should it be. We're doing it through this systematic formula, x minus 3 by x raised to power 7. Whatever term it will be, would you agree that this will be 7c 7cr a 7 minus r and b r? Would you agree? Whatever
Yeah.
it will be something. So I'm separating the numbers and the variables. So I'm writing 7cr into minus 3 raised to power r into x raised to power 7 minus r, and I'm taking that in numerator become 7 minus r. So if I just look at the x, this is now x minus 2r. So it needs to be equal to x raised to power 1. When will it be 1? It will be 1 when 7 minus 2r is equals to 1, 6 is equals to 2r, r is equals to 3. When r is 3, then the power of x is 1. So we needed the coefficient of x, means x raised to power 1. So coefficient of x is 1 when r is 3. So the only constant term are these two, 7cr into minus 3 raised to power r, and value of r in this case is 3 minus 3 cube. So the coefficient of x in the expansion will be 35 into minus 27, 945, minus 945, minus 945. If you have time, no consecutive class, we can still try question number 11.
Okay. Okay.
Okay. Go for it. Try that. Now we have to try term independent of x. That means x raised to power 0.
So this is x raised to the power 0.
Yes. Question 11 is x plus 1 over 2x squared raised to power 9. So first we write it in generic form, 9cr A 9 minus R B power R. I'm separating the constants, multiply by 1 over 2 raised to power R, and the variables x raised to power 9 minus R into x raised to power minus 2R. So x raised to power 9 minus 3R should be equal to x raised to power 0.
Yep.
Therefore, 9 minus 3R equals 0. 9 is equals to 3R and R is equals to 3. So the term independent of x is 9C3 into 1 over 2 raised to power 3. 9C3 is 84 into 1 by 8.
10.5.
1 by 2, 10.5. Now, this is like 11.1 and 2. In your free time, do try mixed questions. Some from Pascal's triangle and some from this exercise.
Okay. Because I also have the book as well, so I can just do it from that.
Sorry?
I also have the book as well, so I could also. So like these questions are the same, even though it's a different
Yeah.
edition.
No issues. Same book. I think I've
Yep.
shared this latest edition with you.
I think so, but I also have the other one, the older edition, but the questions are exactly the same.
Yeah, they're the same. I'll share this again.
Okay.
Anything you would like to ask?
No, no question.